Okay, now we're into solving larger systems of equations, and they ask us to do back substitution. I guess I've heard that term before, but what it really means is that we start by having one of our variables solved for. Well, let's say almost solve for. So if 2z is equal to 4, then we can pretty quickly solve for z. Then we back substitute into the next equation, negative y minus 3. And instead of writing, I guess I'll make it as clear as possible, negative y minus 3 times 2 equals negative 2. All right, so negative y minus 6 equals negative 2. Negative y equals 4, or y equals negative 4. Okay, so now we have z and y, and we'll back substitute into x plus y minus z equals negative 1. X, y is negative 4. And z is 2. Looks like x equals 5. And that's back substitution. Probably the easiest way to solve a system of equations. Okay, and this is a system that has x, y, and z in 3 separate equations. It's helpful to label and it's just more going on than just back substitution. It's helpful to label your equations and then come up with a plan. Number 1 has x and y, number 2 has y and z, and number 3 has x and z. So let's try, we can solve the first equation 1 for y. We can substitute that into equation 2. And then we can work with that to combine that with equation 3. So there, you can use elimination, you can use substitution, you can use a combination. And here I'm going to use a combination. So I'm going to solve equation 1 for y. And I get y is equal to negative x minus 2. Now, I'm going to substitute that into equation 2. Y plus z equals 4. And so I'm going to substitute negative x minus 2 in for y. And I'm going to add that to negative x plus z is equal to 6. So I've got this equation, which is, we'll call that 2 prime because it's basically we put a couple of equations together. Now I'm going to combine that with 3. And when I look at, I'm going to do elimination here because my x's will cancel. So actually it looks like everything will cancel. So when I combine this with 3, so 3, I'm just going to rewrite it here, x minus z equals negative 6, and now I'm going to underwrite it, my combined equations 1 and 2, I get negative x plus z equals 6. All right, when I combine those, I get 0x, 0y equals 0. So what that means is this is, it doesn't have one solution. It's called a dependent system because it has many solutions. So dependent. If you solve it and your variables go away and you're left with a true number statement, then it's dependent. If you solve it, your variables go away and you wind up with a not true statement like I don't know, 0 equals -5, then we call it an inconsistent system. So it either has one solution, or it's dependent, or it's inconsistent. Okay, I'm going to stop this video because the next one problems probably going to